Good day, class. Today we will be talking about transformations. And transformations have a very significant role in mathematics. Transformation is when you transform one object to a similar object or the same object. But today, however, we will focus on rigid transformation. Rigid transformation, especially on triangles, is when you move one triangle to another triangle without affecting the dimensions. Just like, for example, this mouse. If I move this mouse to the left, there is movement. However, it is the same mouse. The mouse did not shrink. The length are the same. The height are the same. So that is rigid transformation. So that's our topic today. And there are three types of rigid transformation: reflection, rotation, and translation. Well, in reflection, it is just a mirror of the object. So for example, this triangle here, this triangle was moved to the right, and there is a dividing factor there, which is called the reflection line. So this triangle here was moved to the right. So it's called a flip. When you say a flip, look here. Why is it a flip? Because A in here, okay, let's identify. A was moved to A in there. B was moved to B in here. C was moved to C in here. Just like in a clear water, wherein from afar you can see a building, and in the water there's another building there. There's a reflection. So reflection is a transformation across a line called the line of reflection. So this is the line of reflection. So it flips, like your hand, it flips, flip. And each point and its image are the same distance from the line of reflection. So for example, from A to the line of reflection, it is the same as the image to the line of reflection. The other one is rotation. When you say rotation, as if it is tied to a nut and anchored to a corner here. And in this corner, it will swing left, right, or right to left. It swings. So it swings with an anchor at the base or tied to a point. It is a transformation about a point called the center of rotation. And each point and its image are the same distance from the rotation point. So for example here, the rotation point is here. Okay? And this E, when rotated here, going here, is the same point as that. So if that is 10 centimeters, this is 10 centimeters. And they normally make a 90-degree angle here. Okay? So translation is next. Translation is when you move from one place to another, like a diagonal move. Right move, down move, left move, upper move. So I've moved from one place to another, and the top is always the top, and the left is always the left. For example, L. Look at L here. J. When you move here, J is still at the right. L here is lower left. If we move here, L is still lower left. And let us talk more about that in other examples. So as definition, transformation is a change in the position, size, or shape of a figure. The original figure is called the pre-image, and the resulting figure is called the image. So we will be using that term, guys. Rigid transformation is a special kind of transformation that doesn't change the size or shape of a figure. Just like I have said about the mouse, it doesn't change. The same shape, the same size, it doesn't change. And rigid transformation are translation, reflection, and rotation only. Another transformation called dilation is not rigid because it shrinks the size. That is not our concern. Second semester will be dealing with dilation. For example, let's start with symmetry. If you look at yourself in the mirror, you will find out that your left part of your face is similar to the right part of your face. Actually, their sizes are the same. So the distance from your ear to the center of a reflection, just like a line at the middle, is the same distance from the other ear, right? The distance of your eye to the middle is the same distance as your eye to the middle. See? And that is because this is the reflection line. So that is reflection. Left has the same counterpart at the right. That is reflection. And for example, let's take the case of this triangle in the graph. So C here, point C, reflects to, this is the reflection line, goes to C. A goes to A. B goes to B. So it flips over. It flips. The triangle facing at the right suddenly face at the left. So they are face to face. So it flips over. Now that is reflection line over the y-axis. Then let's make another reflection line here over the x-axis. So the B here flips over to another B here. Okay? So the C flips over to another C, and the A flips over to another A, or the A double prime. So it flips over. See, it changes the direction. So the tip here becomes the lowest point. The highest point here becomes the lowest point below. Okay? The highest point becomes the lowest point. Okay? The rightmost becomes the leftmost. Those are what I was saying. The rightmost becomes the leftmost. The highest point becomes the lowest point because it flips over. That is reflection. And another example here, in the graph, you'll find out that Q, for example here, is 6 and 2. But it now becomes 6 and negative 2. So the y here is 2, the y here is negative 2. So it changes. But we will deal with that later on, about the coordinates of reflection or coordinates of translation. Okay? So it flips over. So the P here becomes the highest point, becomes the lowest point. It flips. So we will soon find out that actually what only changes is the y. It changes sign. If it is reflection over the y-axis, it is still the x that changes sign. So that's reflection. Let's move to translation. So in translation, it is transfer. It comes from the word transfer. Transfer without moving. The other term for translation is you slide. Slide to the right, slide to the left, right? Just like your dance. So C, for example, here slides to the right and occupies a space here. And the C maintains its topmost position. A shifts to the right, and it is still A here. And it maintains the right position. B shifts to the right, and it maintains its right position. Unlike in reflection, it flips, it will extend both ends. B, when it goes here, will be nearer here. But in translation, they maintain the same shape and sign. For example, here, It just moves, right? It moves there. Unlike in reflection, it flips over. It flips over reflection. But in translation, it will just slide to the right, slide to the left, slide up, slide down. That is translation. So for example, this translation here is a slide down, diagonal. But another way is to slide down and slide right. Okay, so this is a slide. Look at the top position here, A. If you slide it down, it's still the topmost position of A. See, if it is B here, if you slide down B, it goes here, it is still facing the right. B is facing the right. If it slides down to the new position, it still faces the right. So that is translate. All that you need to do is slide. Slide it down diagonally, slide to the right, slide to the left, slide up, slide right, slide left. So that is translation. For example here, when a plane is moving straight from the initial position, here, it moves to the position going to the left. That is a simple translation. Okay? However, when it veers to another position here, when it veers to another position going here, not diagonally, but it swerves, that is already rotation. From this position here to here, that is rotation. Okay, so that is our next move. How do you rotate? Okay, how do you rotate? For example, how do you rotate from here to here? Rotation is a different thing because the tip changes. For example, in the model above here, the model, this model here, when translated down, it appears this way because the tip goes here. Okay, this tip goes here, the tip goes there, the tip goes back. In the same manner as our illustration here. Let's start with C. Okay, C here. It is a counterclockwise. Counterclockwise, if it runs counter to the movement of the clock. We call it counterclockwise. Okay, so it moves here from C. It moves to this part here, and the point of reflection is from here to the origin or 0 from C. That is the point of reflection, point of rotation. You'll soon find out that this part here is a right angle. Okay? For example, B. B from here to here moves to a B here. And that is again a right angle created. So that is 90 degrees counterclockwise. But I want you to notice here how the figure changes. This one is upright. This is upright. But when it goes, it rotates to the left or counterclockwise, it is lying down. When it rotates again down, when it rotates down, it is pointed downwards. When it rotates again to the next level, 90 degrees, it is pointed to the right. And when it goes back, it is again pointing up. So that is rotation. The positions changes. The positions changes. See? As you can see, the tip changes. So this is what I was talking about, a 90-degree anchor. So P here, there's an imaginary line to the origin. If you move to the next quadrant, which is counterclockwise movement, there is a 90-degree line here. Okay, so for example, Q. When moved to the other quadrant, Q maintains the topmost position here. Look, observe Q. When it goes to the other side, it faces the outermost part to the left. When it goes down, Q will be facing down. When it goes here, Q will be on top, and it goes back. So there is a movement. It is like, for example, here as I have illustrated, this part here, when you move sidewise, okay, it's here. Move it more than down, it goes down. So that is the movement of a figure. In a triangle, the position of the tip changes. The position changes. It rotates. That's why it's called rotation.